Welcome back to Calculus 1, and today we're going to be talking about U-substitution. So U-substitution is an integration technique that utilizes the relationship between the derivative and the antiderivative, also known as the integral, to find the solution to it. So the steps execute U-substitution. Choose a U from the inside of the integral or from the expression such that when the derivative of U is taken, it is equal or differs by a constant factor that can be plugged into the expression. Since finding the antiderivative is much harder than finding derivatives, we'll spend more time on it today. So let's practice. So we know that the derivative of x squared plus 1 is 2x, which is what we see right here. So we say u is equal to x squared plus 1, and du, we're going to take the derivative of u is equal to 2x dx. So this is what we'll plug in. So this could be equal to, so now that I'm trying to rewrite the integral, I cannot just put -1 and 5 here. That will not work. I have to plug in -1 into u and 5 into u. So I have to do 5 squared plus 1 is 26. Then -1 into u would be -1 squared, which is 1, plus 1 is 2. So that would be our expression. So then I would have u to the 5th du. So now, as we learned last week, this is just going to be the reverse power rule. So it's going to be u to the 6th divided by 6th, and then 26, 2 to 26. Then we'll have 26 to the 6th over 6 minus 2 to the 6th over 6. We have 26 to the 6th. That's going to take a little while, so we'll move on. All right, here. So, well, we know that if we're just looking at the power rule solely, we know that this is a constant, so when you take the derivative of a constant, that we can ignore that because that's going to be 0. So when you take the power rule, we know that this power is going to go down 1. It's probably a good idea that we set this to our u, and we set this to our du. The du will always be on the outside. So if we say our u is equal to x to the 4th plus 5, then our du, and then we'll take the derivative of u, would be 4x cubed dx. Now, when I said at the beginning of the video where we had to, sometimes it would differ by constant, like 4, we have to divide by that constant, so we're going to divide both sides by 4, which means that we will get 1/4 du is equal to x cubed dx. And that's exactly what we have here. So then when we rewrite this, we can take the 1/4 out because that's a constant. And we can just put du in terms of, we can just replace du with x cubed dx. We already took the 4th out. And then we would just do u to the 7th du. And then this would be 1/4 times u to the 8th over 8 plus c is equal to u to the 8th over 32 plus c. And then we have to plug in back, you have to plug in u back. And we said u is x to the 4th plus 5, which is going to be x to the 4th. We should use parentheses here, x to the 4th plus 5 to the 8th over 32 plus c will be your answer. Okay. So, like we said, we notice that the pattern is that when something has a lower power, or a power -1, when we're trying to make connections between derivative and antiderivative by the power rule, what we can do is we can look for the one that has a differing power by 1. So this has a higher power of 1 by 1, which is 2, and then 2 minus 1 would be 1. There's imaginary 1 here. So we can do u is equal to 1 minus x squared, because remember the derivative of a constant is 0. Then we'll take the derivative of u, which will be du is equal to -2x dx. Right. So same case like we had the previous problem. We have to, since it differs by constant, like I said at the beginning of the video, you have to divide by that constant. So it's going to be -2. So there we go. And then it's going to be -1/2 du is going to be equal to x dx. Okay. So now we can rewrite it. Remember, this is a constant, so we can take it out. And then we will have du on the top, and then the square root of u on the bottom, and then we can just take the antiderivative Well, it's going to be negative half times the integral. It was going to be negative half times the integral of u to the negative half du. And then it's going to be negative half. And then u to the half divided by a half plus c. This is going to equal negative a half times 2u to the half plus c, which is going to equal negative u to the half plus c. And we said u is 1 minus x squared, which means that it's going to be negative square root of 1 minus x squared plus c. All right. Last but not least, remember the pattern that we saw where we had a power greater by 1, which would be x squared and x. And this is also where we would make the connection between the special derivatives from the derivatives and the antiderivatives. So we're going to say u is equal to x squared, then du is going to be 2x, and like the last two problems, they differ by a constant, so we must divide by 2, so we can cancel that out. It's going to be 1/2 du is equal to x dx. Okay, then we can take the half out because it's constant, times the integral of e to the u du. Okay, so yet we don't know how to evaluate this. But if we go back to our derivatives, the derivative of e to the x is always e to the x, right? So if we repeat this over and over again, it's still going to be e to the x, right? So since the derivative and antiderivative are inverses, it's going to stay the same. So it's going to be equal to 1/2 e to the u plus c. Then we'll plug in u into the u there. It would be 1/2 e to the x squared plus c. And that's how you would do it. And we also made the connection between the derivative and antiderivative. I hope you learned something new today, and I'll see you next week.